Okay, so in this video, we're going to look at, in chapter 6 of the AutoCAD book, number 5. So what we have here, as you can see, is a multi-view showing off what the part's going to look like. We've got the front view and the side view in a full section. To give a little more context, though, what we're looking at is a part about like this, right? You've got essentially a flange with some holes and a little threaded portion. And if we want to look, we can cut it in half. I'll show you kind of the section view that you're seeing. Now this is Inventor, but it sure does do a great job of painting a good picture there. So yeah, that's what we're looking at is we're going to essentially create this dude. We're going to start with a revolve, and conveniently, Inventor does paint a very good picture of what we're going to do. So I'm going to show that off. I'm going to end this section real quick. And so what we'll do in AutoCAD is we'll draw a sketch, essentially making the profile of half of it. It's hard to see there, but if we look closer, essentially like this, okay? And then we will do revolve to make the full body. Then we'll go in and cut out a hole, do a polar array to pattern it around. We'll do our chamfer over here, a fillet here, and then we won't do threads because AutoCAD doesn't do threads, but that's the process we're going to take. And so based on the position here, this is our front view, so we will draw on the side view. So I'm going to change it from world in my 3D template to right side view. And I'm going to click atop and rotate it so that we stay in the correct world position here. The reason I'm doing this is because when we're looking at this, we're going to draw the side view, this portion. And then, in order for it to be correct, we have to be on the side. Otherwise, when we get done, we're going to be on the front view. So conceptually, make sure you're on the right with Y up. Okay. And so, if we take a look here, there's a lot of dimensions to pick out here, but for what we're doing, we're going to be drawing half of this. You could technically, like an Inventor, do like parametric stuff and make it a little easier to size it up, but it's also pretty time consuming. So we'll just essentially take every dimension we see and half it. So we know that the overall is 110, and that's the length of this line. We'll do 55. From like the midpoint up, and then we'll kind of work around. And so we have a few dimensions that may seem a little muddied at first, but when you look closer, it's fine. At first, you may think 8 is for the width of the flange, but then you see it doesn't line up, and you realize that actually that's for the hole. So when we're drawing at first, we're going to kind of ignore the hole part in here, and we'll just work on doing the rest. So the actual flange width is down here at 6. And then the other part that may seem questionable, well, two parts really, is we have 16 from the end to what you can't really see. Now what that actually is to that vertex right here. If you can see where my mouse is, right where the R.075 radius is pointing, that's going to be the 16. And then we have 0.15 for the other side of the vertex. Essentially, we have like a really, really narrow chamfer. You can kind of see it better here, but that's how we're going to get to that. And then in case you have not taken a class on fasteners yet, this is a thread callout for that thread I showed you in 3D. And so for all intents and purposes, all you need to know is 1.625 is the diameter. Unfortunately, this is a metric part. So that means you're going to have to do some conversion here. So, you can do two things. I guess you could do like, 1.625 times 25.4, which is like the going rate. I would just go on Google and Google it. So let's see. It was 1.625 inches to millimeter. Bam. And so what we'll use is 41.275 when we get to that step. So let's get into it. I'm going to move this guy over to my left so I can see it while I'm drawing. I've already got my line enabled, and I'm just going to start arbitrarily somewhere on a grid point. I always like to have them on a grid point. Okay. I'm also going to draw with ortho on. That way it's a little easier to jump around. So we'll start with that line that I was talking about, the 55, which is half of 110. Oh no, guys, I'm on the wrong template. Okay, pause. Let me open a metric. And let me close this original. Well, as you can see, it happens to anybody. All right, so same deal. We're going to switch this to right side view. We're going to make sure that Y is facing up. And we're going to start on a grid point. And 55 up. Here we go. All right. The width of the flange is 6. And hopefully you're following along as we go. Technically, there's many ways to go about this. We've got like a lot of points. So what I'm going to do actually is draw our center line. And if this gets too visually complicated, I may start to throw in some layers. But for what we're doing, we were just going to know that the flange is sized up. And from here, we're going to offset this line to get our other points. And then we'll offset this line to get our points. And we'll kind of just round it out as we go. So looking at it, our next hump is going to be that 16. So I'm going to offset that. And then we know that we'll add in the 0.15 in a minute. Might be a little bit easier on the eyes. So the 16 is sized up as being 60 in diameter. We can see that in the left side view. Basically, they have to jump around because it's so visually difficult to cram it all in one spot. So half of 60 is going to be 30. And to make this a little bit easier on our eyes, I'm going to go ahead and trim out some of this. Now, it's worth noting, because this is 3D, we can just trim out everything but the hard edges we need. So I'm just going to get rid of all of this here. And then eventually we'll add in more. But let's go ahead and do that 0.15. It's so little. So little. And essentially, we're just going to draw a line from corner to corner. And I mean, it's little. But when we delete this guy, and we delete the farthest one on the right, we're left with this. I'll go ahead and trim the excess here. And as you can see, it literally looks straight almost, but it just barely protrudes this direction. So, okay, moving on. So the next hump we have is, let's see, it's called out by that 1.625 18 UNEF whole note. So as we know, we have a value that we converted here. So we're going to use 41.275 divided by 2 to find the diameter. So I'm not the best at math, so I'm just going to enter that in here in a calculator. And so that'll be 20.6375 that will offset this line upward. All right. And let's see. It's going to be 23 offset this way to the left. Huh. Seems so insignificant. Did I type a wrong number here earlier? Oh, it's down here. I did. Darn, I did not even realize. Well, shoot. Okay, well, that's fine. So we'll just have to redo a little bit. No biggie. We'll delete this guy. Offset the 0.15 to the right. We'll reconnect the dots here. Okay. I'll trim that bit there. Take two. And so the next part, we can just trim what we have. And so we've got most of our shape. So now we need to make the final neck of the part, which is shown in the section view as 32 or 30.5. And so rule of thumb, you know, it's a tolerance. You're saying like within a range, make it one of these values. So, you know, this allows the people who are fabricating it to nail the part shape. So I'm just going to choose the top two values. They're a little easier to work with. You know, you're welcome to choose whichever. But obviously when you detail it, you want to make sure to note both. So I'll do 32 divided by 2, which is 16. And that's going to be our landing spot. And then it's 42.5 from the end. Okay. And just like that, we've got most of the shape. So now we got to cut the holes out on it, right? And so looking, if we do the hole that is through the entire thing first, let's see. That hole size is 20, so half of 20 is 10. We'll offset that up. And then for our counter bore hole, the hole on the back, we're going to go ahead and offset that depth of 8 from the right side view. And then we'll go ahead and offset the diameter, which is, I'm going to use 36, so half of that is 18. Okay. Getting a little convoluted here, but I'm just going to trim off some excess stuff to make it a little easier to visualize. And so here we are. You know, we've got most of our shape. We just need to trim out this edge. And because it's 3D, this edge. Technically also, we want to trim this, and we're going to use this as our center line, this guy here. The cool part about 3D is you kind of make the hollow part always. So, you know, we can delete this line later, but we've got our main shape. And so from here, you know, there's a couple of ways to do it, but if you go and try to do a revolve just as it is, what you're going to find is you try to select it, it doesn't let you. You know, you can select everything, hit enter, and, you know, we could choose our axis. Type in 360, but the problem is this makes a surface. And so what we're trying to do is actually a model that is solid. So all you have to do is select them all, every bit of the geometry that we want to be in a single profile, and we can type in join. And so now, as you can see, it's converted 12 lines into one polyline. And just by doing that, when we go to do our revolve, it will make it solid, which is super chill. That's all it takes. So I'm going to select my profile, right click, enter. I'm going to choose the axis, which is just endpoint to endpoint, and then type in 360 for our degrees. And so now we have one solid body. All right, so from here, next step, we need to, what we can do, you know, we have multiple things, so we can kind of pick and choose, I guess, but let's go ahead and do the chamfer. I don't want to forget those. They're so little, I might not notice them. So on the solid tab, we have chamfer edge we can choose, and it's going to be this edge here, and it's 0.3 by 45 degrees. Now that's convenient because I don't think there's a way to put degrees, which blows my mind. Surely there is, but you know, if you do see a way, feel free to comment in the comments because I don't know of one, which blows my mind. But it's 0.3 by 45 degrees, so that's 0.3 by 0.3. So So I've entered 0.3 twice. I'm going to right click, enter. I'm going to hit enter, and there we go. We now have our lovely chamfer, as you can see there. Up next, we need to do a fillet, and it's going to be the next edge over, I believe. Let me make sure. Yep. And so I'm going to choose that edge, and our radius is 0.075. I mean, it's little. That's real little. But we're going to go ahead and hit enter, and enter again, and there it is. So now we just have our holes left. I'm going to actually change my UCS position here so that we're back in world. And I mean, I drew it way up here. I didn't even think about that, but that's okay. So we will do a front, and then we will grab the gizmo and just snap it to the front face. Ooh, that center mark would be perfect. Oh no, but it made it crooked, so not perfect after all. All right, so let's try snapping it to one of these vertical lines up here. I would imagine the reason it came in all skewed is because circles are round, you know? There's a lot of angles going on. So let's try just snapping it to... Actually, you know what? This right here, this vertex would be great. Yeah. Reason being is because we need to draw on this face or the backside, either or. And if it bothers you, if you have your grid on and it bothers you, just put ortho on. And, you know, you can just move directly left and then directly down. And, you know, that gives you kind of the look of like, oh, you know, my plane is drawing on the face. So if it's easier for mine, go for it. So from here, you know, we need to draw a circle. And I might have some problems here with projection. So I think that, let's see, what I want to do is actually grab this original endpoint and draw up arbitrarily. And I'm actually going to move, I've changed my mind. I'm going to move this grid to the back side. It would be easier to draw it from there. So we're going to snap it right there on the quadrant. And, you know, just in case it does matter to you, it really doesn't to me, but I'm going to move it just so that the plane itself, the grid is visually aligned to it. But I'm going to do a top view. I'm going to rotate because it always likes to jump around. And we're going to draw a circle on the back side. And it's going to be the diameter of our pattern, which is... Actually, I need a diameter. So let's choose center diameter. It's going to be 88. And so where these two intersect, I'm going to draw a circle. The size that is 8.334. We'll go ahead and just do a press pull. Ah, that's right. Okay, so we're going to trim. And one more. There we go. Okay, so now we'll do a press pull. I'm just going to pull it out, and it cuts it. So now we've got our hole, and we can do a polar array. To be fair, I don't think I've ever actually done this. We'll see if it lets us. It will not. Well, poo. There's got to be a 3D polar array, surely. Interesting. You would think that you would be able to. Is it only tied to 2D, really? Yikes. Okay, yeah, I feel like you probably could do like a copy of it, copy this whole, but because it's one body, I guess what we'll do is go ahead and draw the rest. Wah, wah. That's okay though. You know, it's the same process, so we can just do a line that goes this way, and I'm going to draw these relatively sloppy because we don't have to keep this sketch geometry. It's just for construction. So we'll draw a circle out in space that is 8.334. And we're going to need to make these equal. So we know the quadrants, right? That's pretty straightforward. From here, we want to put the snap on 45, 90, 135, 180. Make sure you get that green projection when it snaps. Gonna do the same thing over here. Same thing over here. And there we go. So now at every crossing, we'll just snap on one of these guys. And so I'm going to do a copy. Let's see. Is that one? I think it was. Grab the center point, and we'll just hit that quadrant, intersection, intersection, quadrant, intersection, quadrant, and intersection. And I don't think you can grab multiple profiles at once, but we'll see. I'm just going to go ahead and delete these so I don't have to trim them. And we'll delete that circle. Okay, and so let's see if we can do them all at once. No, but you know, it's pretty quick just to grab them. Notice I'm just arbitrarily pulling past it. If you say it goes through it, you know, it's more likely to do the proper Boolean operation. So, but yeah, you know, so had a few hiccups in there, but that's how you go about it. You know, when you really look at it, it's not too complicated. It's mostly just making sure that you've got one, your UCS in the right spot. Two, you're making sure you have a polyline for your revolve. And then three, just making sure that you're grabbing the right points. So I hope this helped. If you have any questions, just let me know.